Good morning, everyone. My name is Dr. Siddharth Singh, Assistant Professor, Department of Electronics Communication, Faculty of Engineering, University of Lucknow. Today, speak about the signal processing. What are the basic outline of the signal processing course structure? The brief introduction about the signal processing course. Here, the basic outline of the signal processing course. The main, first of all, you have discuss the course objective of the signal processing. You have know the basic understanding, fundamental concepts, analyze and the design the signal processing systems, apply the techniques to the real world problems. Next, you have discussed the course outline. In the course outline, you have divided into 5 units. First unit is the review of the signal processing and basics of the digital filters and the introduction about the various transforms are used. Like you have studied the discrete Fourier transform, discrete cosine transforms, and the properties of the discrete Fourier transform and the cosine transforms. And also you have studied the fast Fourier transform, it is the algorithmic approach, and you have studied the basics of the finite impulse response filters and infinite impulse response filter, design techniques and the structures. And next unit second, you have studied the introduction to the multi-rate digital signal processing and effects of upsampling and downsampling of the signals, applications of the multi-rate signal processing, subband codings. And the unit third, we have discussed the estimations of the spectrums using discrete Fourier transforms, finite duration signals, non-period parametrics methods for power spectrum estimations. And unit fourth, you have studied the short time Fourier transform, and you have studied the continuous wavelet transform, discrete wavelet transform, and you have studied the time frequency tattling, scaling, and the various wavelet functions, and filter banks, various filter banks of the wavelet transform, like Dove cheese, and so many. And unit 5, various FIR adaptive filters, steps, descent adaptive filters, LMS algorithm, and the basics of the medical signals like ECG analysis for the real-time environments. And then begin with the signals. What is the definition of the signal processing? Signal processing is analyzed and modified this and the sensitized of the signal. And you have the importance of the signal processing in the various fields like communication, audio, and the image processing. In the biomedical image processing, there are various importance in the biomedical image processing. Is a very popular area in the nowadays. Then you have basics about the signals. You have studied the basics types of the signal. You have also know the continuous time signal, discrete time signals, periodic and aperiodic. It is called non-periodic signals, and deterministics and random signals. This is the basic class of the signals. Then you have studied the signal properties. You have also know the amplitude, frequency, phase, and energy properties of the signals. You have also know the even and odd signal properties of the signals. And you have studied the periodic and aperiodic signal properties, the important properties for the signal analysis point of view. Then you have studied the basics of the Fourier analysis for the Fourier spectrum analysis. You have studied the various Fourier transforms like a discrete Fourier transform, and the fast Fourier transform, it is the algorithmic approach to find out the discrete Fourier transform. You have also studied the basics of the FFT, like two Redis to FFT transforms, and then applications of the different application like filtering, modulation, and the spectral analysis for noise cancellations purpose. This is the signal processing important applications. Next, what are the basic filtering techniques you have studied? You have also know the low pass filters, high pass filters, band pass filters, and band stop filter. This is the elementary filters to use any continuous time signal processing. You have also know the basics characteristics of low pass filters in analog signal processing course. You have also know the low pass filter. Your low pass filter you have passes the low frequency and stop the higher frequency. High pass filters you have the passes the high frequency and stop the uh, low frequency. You have also know the basic characteristic of band pass. You have passes the particular band of frequencies. You have know the band stop. You have stop the particular bands, and you have also studied the filter designing. You have also know the Butterworth, Chebyshev, and the different FIR filters. These are the basic filters. Uh, the basic characteristics of filters. You have also used the different filters for the different applications like noise reductions for the filtering operations, signal separations, and feature extractions. Then you have studied the various mathematical tools to process the signals like jet transform and Laplace transform. You have also studied the basics of the jet transform. Jet transform is the power series expansion method, and you have studied the properties of the jet transform. Jet transform is used for the system analysis, stability checking, and the control system analysis. Jet transform is also used for the solving the difference equations. You also study the Laplace transform. Laplace transform is applicable for the continuous time signals. You have also know the basics of discrete time signal processing. Here the discrete time signal processing is various steps. First step is the sampling. Discrete time signal processing, you have used the continuous time signal, then convert in the discrete time signals. The first is there are the various steps to convert any analog signal into the digital signal. The first step is the sampling, next is the quantization, and last is the encoding. These are elementary steps to convert any analog signal to the discrete signal. And you have used the mathematical tool for the spectrum analysis is the discrete time Fourier transforms, and also use a jet transform for the stability and causality, the various criterion to check the discrete time signal processing. And digital signal processing systems, you have used the various applications of in the speech processing, image processing, so on. And you have studied the multi-rate signal processing. You have studied the sampling rate conversion, decimations and interpolations, and applications of the multi-rate signal processing in the audio and image processing and communication systems. And there is the application of the signal processing in the various areas. Likewise, you have studied the audio processing. You have used the various filtering techniques, compression techniques, and enhancement techniques. You have figure out the some example how to noise cancellations work in the audio signal processing. Here you are taking this signals by using a microphone detected ambient sounds. You have cancel out the signals noise by using signal processing applications and provide a noise free signals. This is the most important applications nowadays. Here, this is the image processing applications. You have used the various filtering operations, transformations operations, and the feature extraction operation. Here, you're taking a simple image of Lena, and you are processed by the some uh, processing filters and to enhance the image quality of the output image. This is the simplest application of image processing. Here, this is the biomedical signal processing. You have monitored the various biomedical signals like ECG, EEG, and biomedical images. You have captured the various images by different uh, modality, different machines of humans, and captures the images like ECG and EEG, and you have processed by the signal processing